Okay, the nebular hypothesis. I hope you're sort of enjoying how the solar system formed here. I just think it's wonderful, all the mechanisms and things that the theory offers here, that the hypothesis offers here for forming the solar system, again, from just a bunch of gas that's floating around out there to an actual solar system. I think all these little mechanisms just make this one of my most favorite things to talk about in all of Astronomy 101. I just think it's wonderful. Here's sort of our summary sheet here of all the things that the nebular hypothesis delivers to us here. Hope you see the sun at the center, how the planets formed. Moons are formed similarly to planets, likely some big collisions. I'll talk about that a little bit in this wrap-up, but we saw in previous part of the videos of this class about how the moon formed with a collision with the Earth. Why the solar system is flat. I absolutely love the counterclockwise rotations and orbits, because that is likely left over from that original something that happened way back a long time ago to get us spinning. Like we could have been clockwise, for example, or something had to give us that spin. And so, likely these two things are at least related to that big event back then, although we know things like tidal locking and things like that change the original spins and things. I hope you understand how we get rocky planets near the sun, gaseous planets far from the sun. I'll talk about these asteroids and comets and extra stuff in this particular wrap-up and some of the allowances as well. So just a couple more wrap-up things to come. Nothing too new on the horizon, but hopefully this structure is clear to you then. Again, the frost line is very obvious to draw on there. I think there's the rocky planets right there. There's the gas giants. And, we sort of covered the reasons why that happens. Solar wind from the sun. Only the most durable of elements could have survived in this region way back then. This sort of slide is sort of important here because, as we said, there is this thing called the Kuiper belt way out here, and I'll pronounce it properly with me here. It's not Kuiper belt, Kuiper belt. Kuiper belt. So say it with me. 3, 2, 1. Kuiper belt. Anyway, what the Kuiper belt is just a bunch of stuff. Mostly it's going to be ice and rocks. Way, way, way out that never got used for anything. So be careful you see what the scale is on here when I say way, way out. You can't even see the Earth or the inner planets' orbits on this scale. I mean, this is Jupiter right here and Saturn. So it goes all the way out to Neptune and Pluto, which was always that very last planet out there. So this is very, very, very far away from us for sure, just on the outer reaches of the solar system. And you can even see that Pluto sort of crosses into this region here. And Pluto also has a very bizarre orbit that doesn't even stay flat in the solar system. It's way up high and goes way down low. And Pluto also crosses Neptune's orbit, as you can see there, although the two planets will never collide. They're just not lined up that way. But the key point here is what the Kuiper belt is a bunch of ice and rocks and stuff that was just sort of left over, that just never got formed into a sun or a planet or anything like that. And so what can happen from time to time, and I think we mentioned this when we talk about comets, is two pieces of these ice and rock here that might sort of be moving towards each other, and they might collide. And when they collide, that might send one of these things here sort of heading in this direction, might get sucked in by the sun and start to do a little orbit like that. And that's exactly sort of what a comet is. And of course, as you know, as it gets closer to the sun, the tails will start to come out and all the stuff that we discussed. So comets are definitely explained by the existence of the Kuiper belt. And objects in the Kuiper belt have actually been seen. So the Kuiper belt actually exists. It's not just hypothetical. And the reason why Pluto is not a planet anymore is because as our technology got better, we started to spot more things in the Kuiper belt. In other words, just leftover stuff. They started to see them on telescopes and measure their sizes and things. And what happened is that things larger than Pluto were discovered near Pluto. So what are you supposed to do? Keep adding planets to the list? I mean, right now we have, my very energetic mother just served us nachos. We have the 8 planets. We either had to get rid of Pluto or keep Pluto as the 9th and 10th and 11th and 12th, as we found these larger objects out there. And there's about 4 or 5 or 6 that have been found. So either we keep adding on to the planets and rewriting all the books and have all the students memorize the planet names that way, or we just cut it at Pluto and say, look, Pluto's just too small and doesn't quite fit the definition of a planet, so we just stop there. So anyway, that was what that sort of was about back then. It's really because of technology. We're discovering and seeing things out in the Kuiper belt that could be planets if you're going to call Pluto a planet. Okay. Anyway, onward. So the nebular hypothesis was very good at least the comets in this case. There's also a hypothesized another sort of section of, let's just say, stuff way out, which is called the Oort cloud, again named after the astronomer who hypothesized this there. Now at the moment I believe nothing has been actually seen in the Oort cloud, but it's thought to be there. And again, you can look at the scale up here that they're talking about. So if the this whole thing with the Kuiper belt is sort of that blue dot there, you can see how large the Oort cloud must be. And they're just sort of thinking that what the Oort cloud mostly is billions and billions of comets just maybe either on their way in towards the sun or waiting to come in, something like that. But it's another sort of prediction of the nebular hypothesis that this massive area of leftover stuff, which are comets, of course, mostly dirty ice balls, are sort of out there. Okay, we'll start up with the spins in the next video.